What is up, everyone? What is up? Welcome to the stream once again. Today I'm going to teach you almost everything about Golang's concurrency model. And of course, as you know, I'm going to teach it by example because I'm going to try to mimic some real world scenarios you can encounter in your day-to-day Golang adventure, your mission of mercy in Golang. And for the people that watch this video after the stream, I will make sure there are chapters so you can actually click and skip directly to where you want to go, so you can instantly have insane value at your fingertips, so to say. All right, let me quickly check what is going on here. We have Interstellar, of course. What is up, my man? How is your Sunday evening? Or night, not quite sure. Let me see, YouTube. All good, because YouTube, man, still. All right, so Golang Concurrency. We're going to cover a couple things, and I'm going to try to go as focused as possible to show you these examples. And I will take some time to look at the chat sometimes and answer questions. So if I'm not answering your question, hold on, I will. Let me find the G-spot of streaming. So concurrency, why is concurrency important? And let us be honest, concurrency is one of Golang's best features, right? It's the bread and butter, let us be honest. And why do you need it? Well, I'm gonna give you a direct example. Let's say we have some business logic. Joe Biden, Jared, what is up? Concurrency is an important concept in distributed systems. It is. If you want to be a high-value engineer, you need to know everything about concurrency, and I'm going to teach you this, and I'm also going to teach you the pitfalls, and I'm going to show you some nifty little tricks which will make people sit down if you tell them. Stock exchange as a distributed system. Yes, it is. It's distributed as all right, so what is going on with these small mouse thingies? So let's say we have some kind of application and we have a user ID or a user, whatever, something that can identify a user, right? And what most of the time is going to happen is that we're going to have, for example, fetch user data. We're going to give it the user ID, right? It's going to be an int, and we're going to return normally something from the database or something else, but we're going to return a string to make this a little bit better, right? And we're going to mimic this request because time sleep, request takes time, right? Let's say this takes 80 milliseconds. Sleep time millisecond, like this, right? Okay. Are we already going to return a string? Not yet, not yet. We are already too fast. All right, so we're going to say fetch user data right here, and we're going to say give it a user ID to make it a little bit better. Arcadius, welcome, man. Welcome. Salad, welcome, man. VIP Patreon, by the way. Yes, but let's first of all do a now, which is going to be a time now, and then we're going to say my mic, my autistic. I'm so autistic that my mic needs to be millimeter precision. We're going to say fmt println. We're going to say time since now, like this. Hop. User ID is ID. That's 10. All right. So if we run this, go run main.go. We're going to say 80 milliseconds, right? It makes sense because fetching the user data from our, so to speak, database or whatever is going to take 80 milliseconds. 80 milliseconds, yeah. All right, that's cool, that's fine. But yeah, these times people also have, for example, fetch user recommendations, right? The same thing is going to take a user ID, which is an int, and we're going to say, we're going to sleep again, but the user recommendations, a little bit of AI or something. Arkan, just found your channel and I'm have to take 2 days for free. Yeah, 2 weeks. 2 weeks you need to be. And I'm only just getting started, my man. So fetch user recommendations, right? That's going to take maybe a little bit longer because we are going to do some AI or something. I don't know, let's say 120 milliseconds, okay? So if we say fetch user type hinting, please, yes, user ID, right? So we have a function, for example, you have a function and you fetch the user, you're gonna query the database, fetch the user data, and then if you have that data, then you're gonna fetch the user recommendations, right? And then you basically gonna aggregate this data and spit it out for the user. That's what you normally do in Python or in OGS or whatever in your day-to-day stuff, right? So if we now say run go run main.go, we say it takes 200 milliseconds, right? That's completely normal because we first took 80 milliseconds and then we do another shenanigans. Well, we'll take 120 milliseconds, okay? And I'm going to answer the questions after each chapter. That's going to be more focused. So hold on a little bit. You can already ask them, but I will read them in a later timestamp, right? And if that's not enough, of course, these days, these applications, let's say we have something like fetch user likes. I don't know. User ID again, it's going to be an integer, and we are going to time sleep. I don't know. User likes, maybe I don't have much likes, so let's say 50 milliseconds, right? I'm going to say fetch user likes, like this, user ID. Okay, let's run this real quick again. Main.go. And it could 250 milliseconds, right? It makes sense. Round trips, HTTP round trips takes time. Processing business logic in microservices also takes time. And it does not need to be fetch user likes or something. It could also be something like an API, query some other API, third-party API, right? It all takes time. Luckily, we are in Golang and we can actually use concurrency to solve this chain. To solve this chain of operations, so we can make it as fast as the weakest link. So how do we do that? Well, we can, let me think. Yeah, the thing is, let's return. Let's return, right? We have the point, so we're going to return a string here. And a string here. Which basically will mimic the data. So we're going to say return here, user data, copy this, paste it in here. We're going to say user recommendations. And we're going to say here user likes. Okay? So we could say user data is this, user likes is going to be fetched the user likes, no recommendations, my bad, rex, and then the user likes, right? Like this. And then we're going to say fmt println. I'm building up the tension, right? User rex and the user likes, right? So if we run this real quick, right? So we're fetching the data, we're printing it out, but it took us 250 milliseconds. So how are we going to solve that? We can use something like a go statement, right? A go statement will basically schedule this function onto another. It's not another thread, but it's similar. It's the go scheduler will schedule this into another routine. So we could say go and go, right? Problem is, we have an issue because this user data. Where are we going to use the data like this maybe? It doesn't work, right? So how are we going to solve that? We will need to communicate with a channel, right? A Go channel. So how are we going to do this? We can make, for example, a response channel, which is going to be a string. Actually, yeah, it's going to be a string. In a real world scenario, that should be something else, your own structure that holds some data, right? Any arbitrary data. How do we make a channel? We're going to say make a channel of strings for now, right? It could be anything. It doesn't make sense. It doesn't make any difference. It could be anything. That's a channel. So now we need to find a way to put this channel inside of a function. So we're going to say, we're going to give the response channel here, the response channel in this function, the response channel in that function. Like this. So we need to adjust these functions real quick. We're going to say that the response channel is going to be a channel of string. Response chan string. And the reason why I'm actually doing this from scratch is maybe we come into an issue, right? And then you can see. It's important that you can see issues, mistakes I made, so you don't need to make them. So we have this channel, and instead of returning, because we're in another Go routine, returning basically makes no sense. So we're not going to return this, because we are going to use the channel to communicate, to basically make a synergy of all these functions. So we can actually fire them as sync, right? They're gone. And then we're going to aggregate all these results when they're done, when they're all done. And you will see how it's going to work. So instead of saying return user data, we're going to say the response channel, and we're going to pipe. That's how you communicate in Go. You have this channel, and you can do this syntax to basically pipe to send a message to the channel, right? I'm going to do the same thing here. Response channel, and we're going to do the same thing here. A response channel. Hoppa, right? Cool. So they all will take their time to process, right? To process the HTTP round trip. It's what I call it. Lag, whatever. All right. So these print statements, I'm going to comment these out because they're not gonna work. So how can we actually fetch this channel? How can we read this data? How is it going to work? Well, you could do in Golang, for example, you could range over this response channel. A lot of people don't know this, but you can range. You could say for response, range, just like you would range over a slice or something, over a map. You can range over channels. So we're going to say range over the response channel like this, and then we're going to fmt print ln, just the same way we did here, right? We're going to print out the response. Okay. It's not going to work, but I'm going to show you. May not go. Right? So it actually worked, right? But we have all Go routines are asleep, a deadlock. Joe Biden, this is especially for you. Because what is a deadlock? A deadlock is very simple. It's basically the system telling you that nobody can proceed. The program is locked until eternity. Forever, right? Why? Because we have this channel, we are ranging over the channel, and we get these responses, so it's working actually, but it keeps ranging because it's waiting for new messages to come, right? But nobody's coming, just like your girlfriend, right? So that's the problem. So how do we fix this? Well, we need to do a couple tricks, because in able to fix this, we need to close the channel, right? We need to close the response channel. And what is closing a response channel or closing a channel means that you tell Go, this channel is not going to be used anymore. So everybody that tries to send to that channel, it's not going to happen, which basically also tells the compiler that there are no deadlocks anymore, right? The channel it's okay. Don't lock, don't wait for me. It's all good, we are done, okay? But the problem is, I'm gonna show you. The problem is that, what the fuck is going on? 4.1, this is, I don't know, nanosecond, nanosecond, I don't know. Maybe even slighter, I don't know. And we didn't print. Why is that? Because these guys here are still doing logic, right? They are still here waiting. We close a channel. This guy sees, oh, channel is closed, I'm peacing out. And we print the time and nothing happened. How do we fix this? That's a common problem in concurrency, is that you need to wait till everybody's done. But you don't need to wait in sync, you just wait till the weakest link of the chain is done. And what is the weakest link? Our weakest link is this guy. Fetch the user recommendations. So we know that if we go against the highest speed we can, we will still always wait for 120 milliseconds, right? If we do it synchronously, we need to wait for 250 milliseconds. If we do it asynchronously, we are going to wait for the weakest link, 120. It's almost 130 whatever milliseconds profit, right? Win. And that's huge, right? That's a huge win. And can you imagine that, for example, we do this for 500 milliseconds each, right? That's a long time. So if you can cut it down with concurrency, it's good. So what do we need to do? Golang has something that is called a VG. Can you create clean architecture tutorial in Golang, please? Of course, my man. Of course I can. Go into our Discord, send me a DM or at me in the Golang channel, and I will make a video about it. You name it, I will do it. Yeah, so a weight group. What is a weight group? Basically the same thing as the word says it. It's a group that waits. So we're going to say, is it going to be, yeah, pointer. We're going to say sync weight group. What else going on? Weight group like this. And this weight group has a couple semantics. We can say, for example, weight group add, right? We could say, hey, add 1. And then we can say VG, for example, weight group done. Okay. And then we can say VG weight. Right? So what's happening? If we say add 1 and we don't do this, wait will wait until we say done. Does it make sense? You will see. So if we run this code, basically right now we're going to all go routines will be asleep. You will see, or something like that, right? Why? Because we say add 1 and we wait, but nobody says done. So we have a deadlock. Okay, Joe Biden, especially for you. So now you know why that happens. Cool. So now we wait. Now we know what wait group can do for us. We're going to say, for example, we know that there are 1, 2, 3 functions. So we could say, hey, VG, add me 3 things that needs to be done. All right. Then we're going to wait like this. We're going to wait. So we're going to wait till these 3 are done, right? And then we're going to close it. Then we're going to range. And then we're done. But how do we call done? Well, let's put the VG in the weight group inside of this thing. Right? And this sounds a little bit weird that we place this all in this function, but you could make your own structure that has all these things inside of it to make it more clean, right? This is just kind of a real world scenario, but a little bit dirty, right? You could also do, for example, this, right? You could say VG add 1, 1, and 1. Okay, it's the same thing, because 1 and 1 and 1 is 3. Quick math. All right. So what do we need to do? We need to add the weight group. We're going to say pointer sync weight group. Can we yoink this real quick like this? Hop, and then hop and hop. All right. What's going on? Something is wrong because my formatter is not working. Is it not working? It is. We are good. All right. I'm going to run this and see what's going on. So we add 1, 2, and 3. We're going to wait for them, right? But these guys in another thread routine are going to say done, but we don't do it. So we're going to do it right here. So we're going to say, do our business logic, takes 80 milliseconds. Then we're going to respond, and then we're going to say, hey, we are done. Okay? And then we're going to copy this and basically like this. And normally, I could make a mistake, I don't know. Ooh la la, what's going on? All Go routines are asleep. We need to check what's going on. Real quick, debugging. Oh no. We add 1, 1, and 1. We call done. Oh no, please. Do we need to buffer this? I don't think so. I just did this actually. All right, my bad. So what you need to do in this case is basically buffer the channel here. And I'm not, you can buffer this with, I don't know. I need to check why this is crazy. Wait, let me do it again. Yeah, it doesn't matter. So the thing is, a buffer channel is basically, if you do this, you will process this synchronously, right? So you're gonna pipe into a channel. And the problem is that the other one can send to the channel only if the other one has sent it already. That's a problem. So you need to buffer this. And you could buffer this with, I don't know, 1024 or maybe, it doesn't really matter. What do people use? Maybe 128 or something, right? Doesn't matter. You could make this a variable. My bad. All right. So let's delete this. Go, run, main, go. All right. So we can see what is our weakest link? This one, right? How long does it take? This one. And we have all our data. So we fetched everything asynchronously, aggregated the data much faster than we did if we did not do this with concurrency. If that makes sense. All right. Yes. Are there any questions? I'm going to read the chat. What's going on? Oh my God. Arka, Dan, just on your channel, and I have to, yeah, I already mentioned you. Ansh, Anthony, what's up? What's up, my man? Welcome. Pavel, hi, Anthony. I have a question about the Golang. I have about 100 Go routines and they work with one map. Can there be problems with this in the future? Yes, there will be, and I will show you in a couple of minutes. Because in Golang, maps are not concurrent safe. They are not thread safe. Ice Bear, what up, my man? Congo for 5, 4, 6 subs. It's insane. I have 50 subs today in one day. It's crazy. Can you create a clean? Yeah. RHN, I will. I will do these tutorials. Keke, going good. What's up? What does the buffer again? What does the buffer again? Well, the buffer is basically, the buffer tells, it's basically, it makes, how can I say this? So if this is an unbuffered channel, the next module will make, I'm going to show you what this does. It basically makes sure that if you do not buffer this, right? So if you do not buffer this, what happens is that you can send to the channel, right? But if two people at the same time try to send, they cannot do it at the same time. One needs to send, and if that's done and processed, then the other one can, right? And if you buffer it, everybody can just send. That's the thing. And if you buffer it with 10, you can allow 10 reads or writes to the channel at the same time, if that makes sense. And then it will block again until one is processed, right? And if there are 5 processed, then 5 people can go again, something like that. It's like a queue. It's like a queue, and the buffer means how many there can be at the same time. But they will not be synchronous, right? It will not be, if you run a loop, right? And 10 times, for example, and you put the iterator into the channel, and it's unbuffered, you will get back in your loop here, in your range, you will get back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you buffer it, everybody is going to do it at asynchronous way, and you're going to have inconsistent values. If that makes sense. Yeah, something like that, Joe. Something like that. You will see. Okay, this is the first thing of concurrency. This is basically the only thing you need in your life in Golang to do asynchronous calls and aggregate data, right? Maybe you want to do 10 API calls to 10 different third parties and they all take 100 milliseconds. You're going to wait for a very long time unless you do it like this, and then it will take maximum 100 milliseconds, right? That's the thing. Yeah, Joe, at the end of the stream, I will do some examples so you can actually see much better what I mean by that. All right. The first thing, I'm going to comment this out and go to the next one. Because if you watch this video, that's actually the only thing you're ever going to need, in my opinion. That's basically the only thing I use, and we are doing crazy concurrent stuff on my channel. All right, so what did we do here? By example, yeah, message communication. So we make a new func main, like this. And what I always do as a very common pattern is, for example, something like a server, right? Let's say we're going to make a server or a daemon, whatever you want to call it. And this server, going to have, let's say we have a function. And this function is send message to server, okay? So we're going to send a message to a server. What we can do is, for example, communicate, because let's say here, let's make the server, right? We're going to say S is going to be a server. Let's make this, I don't know, on the heap right now. We're going to make a server, right? And then we are going to send a message to the server. And let's make this. Let's say server start and listen, right? So we're going to make a loop, right, like this, okay? I'm going to say s start and listen, like this, and then we're going to say go run main go. Wait, let me do fmt println sending message, like this. How long has the stream been on? 28 minutes. 28 minutes, but all videos HR are basically saved, so you can actually watch them back whenever you like at your speed. And I will make chapters so you can actually skip all my bullshit and go directly to what you want to see. All right, so we're going to make a for loop here. It doesn't make sense, I know, but we're going to build this up. So if we do this real quick, go run main.go. So basically nothing will happen. We're going to block. Why? Because very simple. We have this for loop, right? In start and listen. We call it here. So basically we are here forever, right? Actually a deadlock, but we are not using channels. So it is what it is. So let's say a very, very common pattern in Golang is if you make a server, right? That some functions are being spinned up in Go routines. For example, if you want to read from a connection or you want to, I don't know, you fire Go routines all the time, right? But you still need to send a message to the server. How are you going to do this, right? It's not safe to just put your pointer of your server into that function and carry your server in your whole application, right? That's bad practices. That's fire material, right? You're going to get fired if you do that. So you need to communicate with the server. How can you do that? Well, we have Golang, so we can say something like, hey, make a message channel. And let's make this a little bit more advanced. We're going to say type message. And I'm using this pattern all the time. Literally in every single series I'm using, in our exchange, in our blockchain, in the poker game, everywhere. If you know these patterns, you're literally the GOAT. You will be. So, and it's very easy, but you just need to know it, right? Because these tutorials on YouTube are very good. Don't get me wrong. Also on Go by example, but it's just by example. It's the basic stuff. Nothing that you're going to use in production. So then you sit there on your screen and, oh my God, how does this work? How am I going to do this in real life? Right, so we're going to make a message. We're going to say from, it's going to be a string, right? Because if you could be a peer on the other side of the network, who knows? And then we're going to say the payloads, right? The payloads, which is basically normally a slice of bytes, right? But in our case, we're going to use a string for simplicity. So we're going to say the message channel, and very good practice in Golang is to make your channels with sh at the end. So everybody knows if we read this, oh, this is a channel, without even, because right here, you're going to say chan message, right? Here we can see that this variable is a channel message, right? But for example, maybe if we say message chan here, nobody, what the hell is this variable? Oh, it's a channel because of these two things, right? All right, so we have a message channel. Let's create. Apparently somebody is dying here, but it's okay. I will help him after the stream. Know your priorities. MSG channel is going to be, we're going to make a channel, right? You know this, we did this before, what's going on? We're going to make a channel and we're going to make it, it's going to be a message. And this time, no string, but a message. You can make literally a channel of everything you want. Literally everything. Could be a map, could be a struct, it could be a giant struct, it could be your own type, which we are using. All right, cool. We're also going to say go, right? Because the server is blocking our whole system. So we're going to say, hey server, go and listen, right? Go on another thread, another go routine and listen. And then we're going to say send message to the server, right? Which basically, I'm going to just show you what's going on. Or nothing actually, but hey. So sending message, but actually it doesn't send any message, right? And the program just stops, right? So what we're going to do is we're going to say here in this for loop, we're going to say the message is going to be, and we're going to read from the message channel, right? So we're going to loop, we're going to block here, we're going to block here until someone is sending a message to the channel, okay? That's what we're going to do. So once that's happening, we're going to say fmt. Actually, I'm lazy. I'm going to say this. Boom. Received message from, I'm going to say %s, and the payloads is going to be this. This should be f, of course, for formatting. There are two strings. So we can say a new line here, and then we're going to say message from and message payload, okay? That's what we're going to do. So we're going to receive the channel, print out what's going on, and then we're going to loop again and wait for the next message. Port is needed. No port, because no, this is a daemon. A server is not always something that listens to a port, right? A server is basically something that serves. That like a daemon, but I know what you mean, Arca. I know what you mean, Arcadius. But it's the same thing, the same principle. All right. So, okay, cool. So send message to server. How can we communicate? Well, we learned that we can communicate with channels, right? The server has a channel and he's listening to that channel. He's waiting. So now we're going to use the same channel to send, right? So they can communicate. It's like a pipe. Okay, somebody is listening and the other one is trumpeting, you know, he's making some music. Send message. So we're going to say, we're going to get the channel here. What channel is it? It's a channel of message. All right. We're going to say, we're going to pipe in. Right, we're going to pipe in a new message, right? So we need to construct one. We're going to say, wait, message is here. Let's call this message channel. So we can actually call our message. If that makes sense. So message, right? What is a message? It's a structure, right? It's this structure. So we need to specify from and payload. So we're going to say, I don't know, who is from? It's from Joe. It's from Joe. Joe. Biden. Like this. Best nickname ever, by the way. Patreon, VIP, Patreon also, by the way. From Joe Biden. And the payload is going to be, you know what? We're going to get the payload as a parameter. It's going to be a string. Okay. So we're going to say the payload is a payload. And the only thing we need to do now is send a message on the channel. And we know how it works, right? It's the MSG channel. And we're going to say this syntax. And then we're going to say MSG and call it a day. Exactly. All right. Let's try this. Main not go. Not enough yo. That's because we need to have the server message channel. And we're going to say hello sailor. All right, we're going to do this again. It's not going to work, right? It's working, but because we are super fast. It's okay. So it works. So we received a message from Joe Biden, and the payload is hello sailor, right? So it's basically this thing. What can we do next? We can do something like this, because now our application basically quits, and I'm gonna force a deadlock, right? How can we force a deadlock? You can say select, and we're gonna block here. It's a little trick you can use if you want to test some, never in production, like this, the way I'm doing it right here. Don't do this in production, to just block. But for our test, we're gonna do this, so I can demonstrate some troubles. So we're gonna say go run main.go. We get the message, but then we are in a deadlock. Why is this? Well, because we are blocking here, but who is sending? Nobody. So somebody is waiting for this channel again, but nobody is coming. You know what I mean? So it's like your Tinder date, you know? So the thing is, how do we fix this? Well, we can say, for example, instead of this for loop, we're going to make it a little bit more advanced. Select. We can make a for, and in that for we can make a select, right? And a select statement is basically like a switch, but a concurrent switch. Let us say that. So how do we do this? We say case, just like a switch, right? Case MSG equals to this channel, which basically means if we receive from that channel, so we can assign to that channel, basically the variable. Hey, Willem Z, what is up? Welcome. We can receive from that channel, right? We can make a case statement about it. We can match about it, waiting for the channel. And then we're going to say, receive message from, right? Is this gonna fix our problem? Who thinks? What do you think? It's the same thing. Anthony, what the hell? You are teaching me the wrong things. Well, I'm gonna solve it. In a switch statement, you can use a default value in Golang, right? If you didn't know that, you can. You can also use that in a select, right? Because why is it a deadlock? Because we're only have one case, right? So we are locked. Nobody is sending. We are locked here. So what we can say is default, right? Which basically means if there is a message, if somebody is sending me a message, well, execute this function, right? But if nobody is sending me a message, execute the default function. And what does the default function do? Exactly, completely nothing, right? So, but it doesn't matter. But we are not blocked, right? We are not blocked because there is the water. Basically, we open the valve and water can now, right? If we have two valves, right? And if this valve is open, the channel, it's weird. If this valve is open, right? Water can stream. But then we at the point in our code, we basically close the valve because nobody is sending messages, so it's deadlock. But thanks to our default case, the other valve goes open, so the water can stream. It's amazing that I've come up with this out of nothing. But that's a very good explanation. If I may say it myself. All right, so let's test again. It's very important because, trust me, deadlocks, you're all gonna encounter these. It is what it is. If you never encounter these deadlocks, then I don't know, then you're not doing concurrency. Go, run, may not go, but boom. So we receive the message. We don't break because we are blocking here, right? So our program keeps running and we also have no deadlock. Hey, is Golang your main language? Arcadius, no, I write a lot of languages. But Golang is the only language that I can, literally, I know the whole standard library on top of my head, almost. And I'm using this because it's easy to write, it's fast, it's super highly concurrent, and that's what I do. I do a lot of concurrent systems, and then Golang is the way to go, right? I also do some Rust. I also do a lot of Rust, actually. But, yeah. And of course, JavaScript and TypeScript and Python, and I can write everything. Go to my GitHub, it's crazy. I even write C#, I even make games. I really do, trust me. All right, in my free time though. Unity and stuff, right? All right, so it's working, cool. So we can send messages, that's nice, right? So we could also do this, right? For example, go send me a message. Start a server in a routine and send me a message in another routine. We can do that. Right? It's the same thing. It doesn't really matter. We can actually do this, right? We can say func. We can make an how do you call this? An anonymous function or something like this. Hop, boom. Wait, this is not. You can write disclosures or anonymous functions or whatever you want to call this. And we're going to say time sleep, right? Sleep me 2 seconds. Like this, and then send a message, right? So we're going to start a server in another routine. We're going to boot up a function in another routine. We're going to sleep for 2 seconds, and then we're going to send a message. Right? You see? 2 seconds, and then we send a message, right? We could actually do, maybe we could do something like, we could make a for loop. Hop. You could say 10, hop. Not sure if it's going to work. This is improvisation. You're going to loop 10 times and send a message. Maybe we should do the time sleep to make this a little bit, let's say 500. Man, time microsecond. That's too macro. Milli. Boom. Let's see what happens. I don't know. Play around with it, right? That's what I do all the time. You see? Boom. Easy. Get all the messages. Communication in Go routines. These are basically 10 Go routines, right? We can make 100 Go routines, right? It doesn't matter. Maybe we can make 1,000. Let's do that. Let's go crazy. Players maybe. Players. You can make your own chat server and everything, right? You see, it's processing these messages at the speed of light. Because they don't take time to process, right? All right, that's that. Let us kill this real quick, because I'm going to show you amazing tricks that actually nobody teaches you. And if somebody does, tell me, so we can do that X a little higher. Let's do again 2 seconds actually. Okay, cool. So a very common pattern that I am always using is quitting a server, a graceful shutdown. How can we do this? How can we do a graceful shutdown? Well, it's very important, graceful shutdown. You need to know that as an engineer. So let's say, and I'm going to teach you the most incredible thing. Although maybe you will not understand why it's incredible, but you will now. So I'm going to say quit, a quit channel, right? So think about this. If you want to make a quit channel, it's actually just a channel to quitting the server. How would you do this? What kind of type would that be, right? I think a string, I don't think that's a good idea. So maybe an int or something, if it's 1, quit, but that's also weird. A Boolean. But what if we could use, a Boolean is 2 bytes, right? A boolean is 16 bits, 2 bytes. 1 byte is 8 bit, times 2 is 16. 16 is 2 bytes. Divide by 8. So the thing is, if you use an int, right? What's an int? 4 bytes, right? And in these economic recessions, we need to be very careful with our memory, isn't it? Right? So I'm going to show you a trick to make this 0 bytes. This is nifty. You can basically go to your engineering team and you could make them sit down. They will say, what the hell, guy, whoa, I didn't know this, man. They will bow for you. You could make this a struct, an anti-struct, right? An anti-struct is 0 bytes, right? There's nothing in it, nothing, right? So we can make this a struct. So how is it going to work? Well, we're going to say case, because there is nothing in it, so we don't need to assign a variable or something. So we can say case quit channel. Hello Novan, welcome, man. Case quit channel, right? We're going to say fmt. Man, this is going very good. Oh, almost an hour. We can freestyle. That's good. I thought this would take too much time. Yeah, I can relax a little bit more because I really want to make this done in a very good time. So we're going to say println. The server is doing a graceful shutdown, right? Shut down like this, okay? Why is this a quit channel? What's going on with this? Did I make a mistake? Undeclared name. Oh yeah, of course, it's S, server quit channel. My bad, guys. So if we got a message, we're gonna print a message, right? If we got a signal that we need to quit, we're gonna do this logic, right? And how does it work? We're gonna do here logic for the server, for the graceful shutdown. What is that logic? I don't know. Depends on your application. Maybe you need to update your database or something, or maybe you need to make sure that all requests are done, right? Maybe people are uploading pictures and they still need to, what the hell is going on here? And maybe they need to be processed and you cannot shut your server down because otherwise he's losing his nude pictures, right? So you need to be graceful. This is the logic that happens here, okay? And then you say, hey, break, right? Because it's a loop, break, okay? And then we are basically here, yeah? And we can say fmt println, and you could say the server is shut down, okay? All right, and there's a lot of things going on here, I know, but we will do this. All right, so we have this weird struct channel, right, with nothing in it, but this is basically a very nice trick. So we're going to say the quit channel is going to be make me a channel of a struct, like this, and of course an empty struct. Boom, done. All right, then we're going to make a function. I'm going to say function quit graceful quit server. I don't know. And then we're going to say give me the quit channel, which is going to be a channel of empty struct, right? And then the only thing we're going to say is we are not going to put something in it, we're going to close it, right? We're not going to pipe something into it, we're just going to close it, right? We're going to say done. So we're going to say close the quit channel, like this. All right. So we have this function, right? It's going to sleep 2 seconds. We're going to send a message, right? But we're going to boot up another Go routine. We can make as much Go routines as we want. Why? Because we can synchronize with these channels, right? We are the magicians of Golang. We are the magicians of the concurrency world. We are Morpheus of the matrix, right? Because this is basically sleeping 2 seconds. We are going to sleep 4 seconds here. Otherwise, bad news, right? So and we're going to say quit graceful quit server, and we're going to get the quit channel of the server right here, okay? Yes, and then yeah, we're gonna just block, because otherwise our program will be done. Actually, we could do, it's fine. It's all fine. We could do so many things, right? We need to choose. Yeah, let's see what's going on. Go, run, main, go. 2 seconds, message, 2 seconds. Oh, what the hell's going on? The server is in a graceful shutdown forever. That's not good. You're gonna probably will make this, will experience something like this. And it's basically unexpected behavior, which is something we encounter each day as a software engineer, right? What's happening, guys? It's very simple. This break statement, this will break actually this case statement. It's a very special way. It's just because that's what Golang does. Normally break would actually make sense to actually break this complete for loop, right? Like what's else going on? Right? I don't use a mouse, that's why I cannot work with it. So we should expect that this is going to break and then we are here and then our server is done, right? But it's not true. That's why we need to, and you probably won't know this, but did you know that you can name your loop? For example, running. This is, what the hell's going on? Well, it is what it is. You can name your for loop. And this, you can name your for loop like this. It's weird that this indentation is crazy. How can I place it here? I can't. All right, never mind. So instead of breaking, here we say break running. And actually, if you want to be fancy, you can say free, and then you're going to say, I want to break free. Exactly, right? So let's run it again. Oh man, why am I a software engineer? I don't know. So we're going to run this thing. We receive the message, and then we are doing a graceful shutdown, right? Here. And then we say the server is shut down. And then we have a deadlock. Why we have a deadlock? Because the select statement, right? So we could delete the select statement. And how can we fix this? We could say, don't do it in a Go routine, for example. Is it? No, it is not. Yeah, but the thing is that it doesn't really matter, right? Because in a real world scenario, the select won't be here, right? The server just quits, and it did what it did, right? It did what it needs to do, what we want him to do. Already saw this in your video. So we received the message, then we closed this empty struct, which basically allows us to do zero memory allocation operations, which is always fancy. If you test or benchmark in Go, you can see how much allocations you do. It's very important. It's the garbage collector. Yeah, it's important for speed. So if you can tell somebody that you can basically communicate with a channel that actually don't take any bytes itself, it's insane, right? It's nifty. And don't steal this idea for a short, because I'm gonna make that. Right. What did you need to remember? This pattern, literally, is this thing is almost the only thing I'm using for these communication with server structs and daemons and all that shenanigans. And you actually can remove this thing. Let me Alright, it's the same thing. It's working perfectly fine now because the server knows, the compiler knows that we are sending this quit channel after 4 seconds. Right? Alright. If you want to make game loops or something, or in a game, or some AI. For example, if you want to make a game, some AI processing, and you spin your AI routine, right? Something that calculates, I don't know, where an enemy needs to walk, and you have these events you need to wait. Events, you can call these events, right? It's a bit the same thing. You have these events that you need to communicate with your AI, but your AI is being booted up in this file, and then you're using it somewhere else. You know how it goes, right? If you're a software engineer, you know that sometimes it's very hard to access something, and then using events, and then you need to make your own event handler, and it's a complete mess, right? And with these channels, it isn't. And remember this one, all right? Remember this one, and remember this free. Very important, break free, all right? Subs are getting higher. It's crazy. I know today is it's insane. I'm not gonna lie, but hey, I need to work very hard for it, my mans. Trust me. I won't recommend this to anybody because it's very hard work, and you earn nothing. Not yet. Right? I'm not at that point, but that doesn't matter. That doesn't matter, because if you do something that you like to do, and especially if the community accepts you, appreciates you, it's insane. No money in the world can replace that feeling. I already told. Are there any questions about this? Because if not, we are going to check something very important, race conditions, because this Golang concurrency is very, very powerful. But you know what I'm always telling you guys and girls, or something in between, because these days, right? You need to be very careful. With great power comes great responsibility. And a lot of people are using these concepts, but you will shoot yourself in the foot because you will have race conditions. And the common problem, everybody makes them, right? It's everybody makes mistakes. That's not the point. But the nastiness, the filthiness of race conditions is that you don't see them coming. Again, like your Tinder date, you don't see them coming. That's the problem. They are there, and you don't know unless a customer comes to you and he tells you, "Hey, my balance should be 200, but I have 150," because of a race condition. All right. Are there any questions about this this pattern concurrency communication with channels? Ice bear, great power comes, yeah, exactly. That's exactly what I mean. All right, then we're going, the next thing what we're going to cover is trust me, this is super, super important. Maybe the most important thing. And that's race conditions, mutexes, and atomic values. Something that a lot of people don't know when to use. And it will make the difference between a good engineer and a very good engineer. Right? It will make the difference between an engineer or a lead engineer or an architect. Actually, developer and engineer is not the same thing. And I think I see ghosts there, but it isn't. But it's maybe the light in my eyes. There's a difference between a developer and an engineer, right? A developer develops things, and an engineer, he engineers. He's the architect of the code. He's the master. He is the higher value person in the team. Don't forget this, right? Developers do npm install, right? That's what they do. They install packages. That's what developers do, right? They packages here, packages there, and they do these things, right? And then they have made something. They developed something. But who is architecting this stuff? Who is preventing them to make mistakes? It's the engineer. He's the boss, right? So I'm going to teach you to be a high-value engineer so you can raise your paycheck with an incredible amount. All right. I'm going to delete all the shenanigans. Actually, I'm going to open up race test. Boom. We're going to say func test data race conditions. That's what we're going to do, like this. Getting a little bit rusty. Race conditions. I'm going to say t testing t like this. All right. What is a race condition? A race condition is basically where two threads or routines sitting on a different thread, routine, whatever, and they're trying to modify reading or writing to the same variable. Right? For example, let's say I want to do a counter, but I'm gonna make it a state, because that's what's most likely going to happen in your day-to-day life. You have some state, and you do some API queries or something. You spin up some Go routines, and you're fetching some data, and you want to do some logic with the state. That's the problem. You have a map, for example. In Golang, a map is not concurrent safe. So if you put something into a map in another Go routine, you will have a race condition, 100% sure, right? 100% guarantee. So you need to be careful. And I'm planning a video on how we're going to make our own hash map, but a concurrent safe hash map. Completely from scratch, with hashing stuff and these buckets and all that shenanigans. Yeah. So, state. That's going to be, I'm going to make it simple. It's going to be in... I'm going to say var state. It's going to be a new int32, an int32, right? And why it's an int32? Because. All right, so let's say we have a Go routine, Go X, for example, and we have a Go routine Y. What's going to happen is that, and they're going to modify the state. So, and X needs needs the value from the state, and it's going to do some multiplication or something, and Y does the same thing. Who is going to be first? Is X going to be first to read from the state and update it, or is it going to be Y? We don't know. It's a Go routine. Who is going to be the faster one? I have no clue. It could be each time a different guy, right? So it's, you already see it coming. It's inconsistent, right? It's bad behavior. It's inconsistent behavior. Very hard to debug. Very hard to test without a real test, right? So always make your tests, because these race conditions, if you're going to test them in your browser or something, or in your API or whatever, or in your terminal, it's going to look that everything is working. Nobody's going to complain. Literally nobody. But there's going to be an error. There's going to be an inconsistency. Sometimes it won't. Sometimes it will. It can go 20 times good. But at 21st time, you're in bad trouble. And you're going to get fired. And you can go back to McDonald's. Yeah? So, how do we fix this? Well, let me give you an example. Let's boot up this... routine, and we're going to say 10 times, and let's say we do, for example, we're going to modify this variable. Actually, what we're going to do is, we're going to make a Go routine. So we're going to say state equals y, right? Can we do this? We need to do this in int32 casting, because y is an int. And then we're going to say, can we do go func? Oh yes, we can. Boom. And again, this is very important to know this. You're going to see this yellow thingy, and it's telling you loop variable y is captured by func literal. Well, what is this? It's basically because this creates another scope of the function, and it captures this y. And to basically fix this, to make this consistent, you need to provide the y into this thing. This y, which is out of the scope of this function, we need to put it inside this one and here. And this is the same thing like writing a function like this, right? Function x, and we say y int, right? Like this. And it returns, and what I'm doing, solidity, right? Caps lock. Oh my god. Return y. This is very important to know, by the way, guys. Return e. This, what I'm doing here, right, is exactly the same thing as this. Keep that in mind. 1.9. Yes. It could be that I miss some of your chats because my OBS communication with YouTube is sometimes it's nasty, and I could miss some of your messages. So please write them again if I miss them. It's not my bad. I'm not ignoring you at all. So that's the only thing you need to know. Right. So what are we doing? We have this state, which is our variable, or state. It could be anything. It could be a structure, a map, or whatever. In this case, it's an int32. We loop 10 times, and each time we boot up a new Go routine, so we schedule this function into another Go routine. So basically, 10 times we're going to increment the state from a different Go routine. Let's test this. How do you test in Go? It's very simple. You just say go test this, right? Everything is fine. We go home. No, you made the biggest mistake in your life. This is a race condition. How can we test this race condition? Well, if you saw my short, we can say go test minus minus race. And what dash dash minus minus dash dash race? It needs to be this. Test me everything dash dash race, right? So what do you tell? You tell the compiler from, hey, test my code, but also spin up a check for race conditions. It's a special thing in Golang. I don't know what they are doing behind the scenes, but they check if you are accessing and reading from different Go routines to the same variable at the same time. If you press enter, ta-da! Race detected during execution of the test, right? Bad news. You have a race condition, right? And it happens all the time, right? Sometimes you forget it, but you need to, after a while of experience, you will see these race conditions already before they are occurring. That's the thing. How can we fix that? You can fix it with two things. A lot of people are using, and like I mentioned, this could be a map. It could be any structure, slice, array, bytes, anything. It will be the same thing. We could use something is what they say. It's an MU. That's basically what I always call my mutex in Go. I always call them by MU. So if you read my code and you see MU, your channel was recently posted on the Golang Reddit. That may be one of the factors of the recent subscriber surge. Yeah, it's maybe that and the short I placed. I don't know, man. I don't know. I cannot post it myself on Reddit because I don't have karma. I literally don't have karma. I have 1 karma. So I cannot do anything on that platform. It is what it is, man. I'll take it. Thanks to Joe Biden. He helped me out. So MU, if you read my code, MU stands for mutex. So if you see this variable in my code, you know, oh, he's using mutexes. Very important. You should do the same. That will be much appreciated in your team or in open source. Or you can use it log. These things you can choose. So an MU we're going to say is going to be, we're going to say it's a var MU is going to be a sync. And we're going to say RW mutex. What is an RW mutex or W mutex? It's a read-write mutex. But what is a mutex? Well, a mutex can basically lock here, right? So that's you telling. It's basically all these Go routines, right? These 10 Go routines are basically spinned up, booted up. And the Go routine that holds the lock basically can read and write, depends on what kind of lock. In this case, it's a global lock. It's locked for writing and reading. But this is, you should lock, I'm going to explain in a bit. So the mutex that, the Go routine, the mutex that holds the lock from that Go routine basically can read and write to the variable. If somebody else without the mutex tries to access that variable, it needs to wait because he doesn't have the lock, right? It's like a game and with 10 people and the guy with the flag in his hands, he can kick your face, right? And the other one trying to beat you up, they can't because they don't have the flag, right? So if this guy beats your face, then he can give the flag to somebody else and then that guy can do it again until you're knocked out, all right? That's a mutex. So how do you do that? You say mutex lock, right? And just after your operations, right? After your biz logic, right? You can say mu unlock, right? So, hey guys, I have the lock. I do my thing. I do my business logic. I'm done with my logic. Here, I'm going to unlock the lock. And the next guy who can achieve the lock can do his thing until he unlocks. It makes that sense? That's what a mutex does. So if we do it, oh man, baby. If we do this again, then everything is good. You see, we fixed our problem. Now we have no race condition anymore. Now we are 100% sure that we don't read and write at the same time from different routines. Okay. But in this case, it's going to be a write. But if you only want to read, you can use an R lock, which is a read lock. And then you need to say R unlock, if that makes sense. But in this case, we're going to write to it, right? We're going to update it with, we're going to increment it by 1. So we need to use this lock instead of a read lock, the write lock. All right. But what is the problem with mutexes? You're going to encounter a lot of issues because, for example, we can have multiple variables, right? Or multiple states here, right? For example, states 2, states 3, and so on, right? So you could say, yeah, but can we not protect them by one mutex? You could, but what happens if you are, let's say you have a lock for state 1, right? And the other routine is willing to write to state 2, but it's the same lock, even though you cannot have a race condition because state 1 is not the same structure in memory than state 2. So actually he can access it, but he can't because you have the same lock for all of the states. What happens? You will have a deadlock, right? You will have a semaphore, whatever. Some nasty stack trace. That's the thing. It probably happened, and also it could be that your application will be slow as F, really, because all these locks are waiting for each other, and it's going to be slow. So always use a mutex very carefully, and all these things also come with a computational cost. Don't forget that, right? Mutexes will slow down your program. So if you can do some cool stuff with channels, try to do it, because you can use channels in order, unbuffered channels in order to communicate, so you don't need a mutex. But I have another nice trick. You can use atomic values, right? So I'm going to remove this mutex real quick. I'm going to say do with the race, so we have back or race condition. So how can we save this? And you have something that's called an atomic value. And an atomic value is basically it makes sure that this value can only be adjusted. That depends. This is actually, I need to be very, very careful what I say, because this is not an atomic value. You can make this an atomic value. You could say atomic value, right? Right. This is now it's an atomic value, right? But that's a little bit more advanced. And if you want, you can ask me anything about this on jump into the Discord, subscribe to the channel, and DM me. And in our community, I'm going to teach you how to be the GOAT, literally the GOAT, right? Check my channel, check my videos, and you know that it's going to happen. So we're going to say back or int 32. It's not an atomic value, but we are going to increment it in an atomic way, which basically means that Golang is going to guarantee us that we are going to update the memory in RAM, that we are going to update that in an atomic way, which basically means that only one will update this at the same time. How do we do that? We can say, instead of the state, we can say atomic add int32. And that's why I made this an int32, right? I was a little bit cheating, right? I was a little bit cheating, but it doesn't matter. An int32 is the same as an int, 4 bytes. So it really doesn't matter. Add int32, we need to specify the address of our state, right? In Golang, if you say state, right, this will point to the variable, right? But if you say end state, right, you will take, what's going on here? You will take the address, which will point to the pointer in memory, which will be 8 bytes. That's the, so you can directly modify the memory, if that makes sense. state, and we're going to say, we're going to add it by an int32, the iterator, which is the exact same thing, right? It's the same thing than this, right? State plus equals int32y is the same thing as atomic add int32 the state with 1. It's the same thing. It's adding one. It's adding the iterator to an already existing variable, if that makes sense. So if we now test it again, I have this keyboard without, I have this very short keyboard, so I need to press a lot of key bindings to use my up arrow. Because I'm actually using J, K, H and this stuff to move around in my editor. So I'm not used with arrows. I'm going to type it because I'm going to say go run main, no, not go test the whole shebang race. And our race condition is solved. We are using atomic values, right? Although it's not really an atomic value, but we are incrementing it in an atomic way. And you could also use, for example, a map as an atomic value or a complete config. And he plans to create a web project. Oscar, hey Gophers, cheers from Guatemala. Welcome, man, welcome here. Welcome to the stream. A web project. Well, I was thinking, if people want that, I can do a lot of videos, man. I can make them at the speed of light, you know that. Maybe we could make our own API, and then how we interact that with Next.js or something, right? We could do that. Why not? Why not? All right, these are data race conditions, mutexes, and atomic values. Basically, the whole shebang. Go concurrency completely completely explained. Are there any questions? What do you want to know? And I will try to answer your question. I don't know how many delay there actually is on YouTube's chat. I have no clue. Sometimes it takes a time before people, I think a couple seconds or something, maybe 5 to 10 seconds delay. No idea, no clue. No clue. Maybe I can explain what the difference is between a buffered and an unbuffered channel. That could be a good thing in the meanwhile. And if there are questions, we can do a little chit chat. You can ask me anything about programming, Go, Python, Rust. It doesn't really matter because we do all languages, literally. Yeah. And let me quickly think about a good way to explain these things. I could say something like, a response channel could be, make me a channel of ints maybe. So atomic values can only work in a Go function. Atomic values, I think a lot of other programs have, programming languages also have something to do atomic operations, but in Golang, we can, no, these atomic values, basically, you can have something like this, right? A server, for example. And we're going to use atomic values in our poker game. Well, you could say server struct, it's not a function, right? It's a struct, and you could say, for example, is running, right? This is very important, that is running is going to be accessed maybe in a graceful shutdown or something. You could say that could be an atomic, what do we have actually? Atomic. You could use a uint8 or something and mimic a bool. Or just a string. Round. Game round. Making game round, right? It's an atomic, it's an integer, so let's say an int32, right? You see? And if you want to access this game round, for example, if you want to make changes to this game round stuff, because your game server is running and it's concurrently and players are doing things and yeah. So you need to make sure that you access this game round in a very consistent way without any race conditions. So you could do something like, let's say server is going to be, man, my keyboard, is going to be a server like this. hop, and then we can say game round is going to be, I don't know, atomic yeah, I need to think about this real quick. But I did this before. How can I say this? N is basically 10 or something, and then I can say load this. Say n 1. Is this working? Probably not. Let me see. Unknown game field around instruct. What did I do? Type server strict. Let's do it here. Let's move this thing out real quick. We already have a server, but that doesn't matter. Wait. I'm gonna try to show you. This is actually improvisation, my man. Let me quickly answer some questions real quick. So atomic values, no, not only in a Go function, can be used everywhere. The main principle of an atomic value is to make sure only one can change and modify that value. That's pretty new things for me, Arca, so I have to take a few steps back to get to the basics. Well, the beginning of the stream is very basic, right? If you go back to the beginning of the stream, it's very basic, building up to how Go routines work and how to communicate with channels. But I need to tell you this about these atomic values and about these mutexes, because you need them. If you do concurrency, you will need to protect your data against data races, so it's pretty important. Loire Noy, I heard the saying that if you can avoid using concurrency, the better, because it's prone to... Yeah, exactly. That's Loire Noy. That's completely true. If you can avoid concurrency, do it, because it's the most filthy world you will go into. Trust me, it's hard, because, man, concurrency is basically, you need to synchronize. In a concurrent world, you need to synchronize, you need to make sure there are no data race conditions. But the problem is, if you do that, you will use mutexes, you will try to use all these complex things, but that will make your program much complexer. That will make your program much slower, even though concurrency solves a speed problem, right? From time to time. If you want to do, for example, data aggregation, you want to fetch all APIs at once, you can spin them up all asynchronously and then synchronize them at the end. So you only need to wait for the weakest link, like we did in the first example of the episode. But it will cause a lot of problems. But that's why distributed systems engineers get a lot of money, because it's important and difficult. Python, huh? Yeah, Ice Bear, Python, good language, but for concurrency, I wouldn't recommend it. Is that the Groovebox team? Yes, my man, it's the Groovebox team. It's the Groovebox Hearts Groove. How do I do this? Install team. What's going on here? Install team. It's the Groovebox Heart, man. I also like Dune, Atelier Dune, where is he? Here. I also like this one. Look at this. Cool, eh? And my favorite of all time, the Naysayer. Wait. You're not gonna like it. 100% sure you're not gonna like it. This is one of my favorites. The Naysayer team. It's basically minimalistic. The most minimalistic team. I'm rocking Groovebox material. Yeah, man. Groovebox is for the real chats. Not gonna lie. Groovebox is old school. It's the OG team. It's been here as probably older than myself. Not sure. Atomic values. Wait, now I'm literally confused. So problem is, if you switch a team, your eyes are uncontrollable. So we're gonna back to the Groovebox boys, like this. Manik, my guilty pleasure is the bearded team Solarized reverse. Yeah, I was rocking the Solarized a long time. GitHub team, yeah, it is. The GitHub team. I have it, GitHub team. Preferences, GitHub. You see, but this is, I don't know, this makes me feel like Atom. Like an Atom developer. How can I actually, I don't have keys, so I need to do this. Oof. What's going on? This is a nice one, the GitHub dark high contrast, right? This feels a little bit smooth. Oof, man, these white themes, what else going on? Yeah. Anyway, this is atomic values, don't worry about it, man, don't worry about it. If you want to use an atomic value, actually now I'm actually curious, to be honest. I'm not gonna lie. Let me delete all the shenanigans. Now I triggered my own mechanism, func main. And I, like this, man. And I swear, this VS plugin, the last days, it's, especially when I stream, is lagging like a madman. Not gonna lie. Server. I'm gonna try to embed an atomic value into this thing real quick. Let's say it's gonna be a game. An epoch, why not? An epoch is gonna be an atomic. It's gonna be an atomic in32. Error, illegal line. What is going on? Oh, it's this. No, I know what's going on. This is the internal package. I don't have it. You see? It's could not import runtime internal atomic. I don't think the normal atomic package has this. You need to be careful with that. You see, atomic, and then, wait. Sync atomic, yeah, I want this. No, the sync atomic only has a value. I remember back in my days, when I was doing the Raft consensus, when the Raft consensus just was released, I was porting it into Golang. And in that time, the sync internal package was still available, but I think you can download it. And then you could have access to these atomic in32s and such. But now you need to do atomic.add, and they changed it. So if you want to do a multiplication or something, you will need to calculate it, and then you will need to add the value to your existing thing, just like we did in the test. Whew. What's your keyboard? My keyboard is the Razer Huntsman Mini. Can I show it? It's the Razer Huntsman Mini QWERTY without any... what the hell is going on? My mic is blocking me. Razer Huntsman Mini with some custom keycaps. I don't know, just to look cool. That's the thing. Yes. I have an advanced keyboard only for the Giga chats. It is, Joe Biden. Let me see. But you cannot show it on the Discord, man. Show me your keyboard. Show me your keyboard. Yes, so we did everything, man. I think if there are no more questions, we can. It was a nice stream. It was a nice stream, man. Very nice. Man, what the hell? This day, I have almost 70 subscribers in one day. That's legit crazy. I'm not gonna lie. The 65% one, yes, exactly. Arcadius. This is crazy, man. It's a good keyboard, but I'm still getting used to it. My best keyboard was the Corsair KGB75 or something. I don't know, or 65. It has these subtle ticks. This one is clicky, right? You see? This one is clicky as hell. Yeah. It's I don't know. Yeah, and it's sticky. I don't know. I need to change it real soon. Back to the subtle keycaps. All right, if everything is clear, then I'm gonna wrap it up. I'm gonna chill for a bit, do some administration on the Discord, helping people out and all that good stuff. So if you liked the content I'm producing, consider subscribing to my channel. Much appreciated. It helps me a lot to get this content for a much wider audience, because otherwise the YouTube algorithm, it really hates me. I only have 200, 300 views. Can you imagine? This content needs to reach a much wider audience because, yeah, and join the Discord, very important, because if you have questions about the streams, if you're following the blockchain series or the crypto exchange series or the new decentralized poker series and you have questions, you can directly message me and ask for help. Yeah. The K70, I think that was a keyboard, Arcadius, but yeah, it was a big one. Yeah, and I spilled coffee over it and it's broken and I was so sad. And it has, and you cannot find these keys anymore. These switches, they don't make it. Even the new Corsair series, the small ones, they don't have it anymore. That's so sad. So I think I need to make a custom one, but man, I don't know. I don't know. It's fine. It is what it is, and it's dirty as hell. It looks like Little Pio is keyboard. If you know Little Pio, look him up on Google, YouTube. All right, guys, thanks for watching. If you have more questions, leave them in the comment, and I'll see you in the next stream. Thanks for watching. Bye-bye.